So, section 6.4, we kind of talked about this, I believe, yesterday, but we haven't officially mentioned this particular figure. Now, you've heard about this figure ever since you were a little kid. Nope. Yeah, I don't know if you learned about trapezoids when you were a little kid, did you?
Yeah.
But you probably, when you were a real little kid, you probably learned your basic shapes, circle, square, rectangle, triangle, stuff like that. All right, and this is one of those shapes. What is this thing right here? Well, actually, you don't really know that it's a rectangle, technically. Now, if you're a little kid and you looked at this, you would tell a little kid, this is a rectangle. All right, because, it looks like a rectangle. All right, it looks like what a rectangle looks like. But in geometry, we're a little bit more specific about it. I can't technically say that this is a rectangle just yet. Okay, but if I did this, that's good. If I did this, if I had a quadrilateral, this is a quadrilateral, isn't it? Because there's four sides, all right? And if I knew that that was a right angle, that was a right angle, that was a right angle, and this one was a right angle. If I knew I had a quadrilateral, a four-sided figure, and all four angles were right angles, then what do you think I could say about this thing? I'd say what? It's a rectangle, yeah, just plain old rectangle. Not a right rectangle, okay? That's kind of redundant, all right? Because if it's a rectangle, it's already got right angles in it. You can't have a non-right rectangle, all right? So we call that thing a rectangle.
Even if it only shows you two right angles, you would say...
No, you couldn't, because it's a good question.
But I thought they had to be supplementary.
Well, we don't know there's a parallelogram, though. See, we didn't know that it was a parallelogram, did we? We just knew we had four sides. That's all we knew, correct? So now, if I told you it was a parallelogram with one right angle, then you could say the rest of them are right angles. Then you could say it was a rectangle. But I didn't even tell you it was a parallelogram. I just said it was a four-sided figure, and that was it, right? So you have to know all angles are right angles in order to say this is a rectangle. So let's think about this. If all four angles are right angles, that means the opposite angles are equal, doesn't it? That means the consecutive angles are supplementary. So guess what a rectangle also is? It's not just a rectangle, it's also a parallelogram, isn't it? Because we said yesterday, if the opposite angles are equal, then the thing's a parallelogram. So a rectangle, it's not just a figure there by itself. A rectangle, let's write this down. A rectangle is a what? Parallelogram. Okay. So a rectangle is a parallelogram, and basically it's a parallelogram or a quadrilateral with what? Four right angles. Okay? So that's basically what a rectangle is. All right, it's a parallelogram with four right angles. Everybody with me? Okay. So that means if it's a parallelogram, there's a bunch of other stuff that's true about this this rectangle, isn't there? So if I know this rectangle is also a parallelogram, what can I say about the opposite sides? They're equal to each other, okay, and they're also what to each other? Parallel, okay, they're parallel to each other. Well, what about these two opposite sides over here? They have to also be equal to each other, correct? And they also have to be parallel to each other. So everything that we knew about, we said a rectangle is a parallelogram, so everything that we knew about a parallelogram must also be true about a rectangle. Look at the opposite angles. They have to be equal to each other, don't they? Because we said it's a parallelogram, and sure enough they are. Look at the consecutive angles. Are they supplementary? Absolutely. What else? What other stuff did we know about a rectangle? We got to draw something else in here. What else did we have to draw? The diagonals. The diagonals. Okay. And they bisect each other, exactly right, because we learned on a parallelogram the diagonals bisect each other. And so far there really hasn't been a whole lot different. The only thing that we've learned new is that a rectangle is a parallelogram with all four right angles. All right, that's really the only thing new. But here's something that we didn't know about a normal everyday parallelogram. Here's something. Look at the diagonals that we just drew. Now we said the diagonals bisect each other. But look more specifically on a rectangle. What else do you think might be true about the diagonals? They're the same distance, so that means they are what to each other? Equal or congruent to each other. Do you see that? I'm not going to go through a proof or anything. I guess you probably could do a proof. Side angle side. Yeah, we could go side angle side on this if we wanted to. Right? So we could say they're congruent. Yep, so we could say they're congruent. That means that this and this are equal to each other. You see what I'm doing? We talked a little bit about that, didn't we? Side angle side, 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 side. Remember that stuff? So look at this triangle right here. This one right here. I've got this side with 2 arcs. I've got an angle, and I've got this side with 1 arc. Everybody see that? And then look at this triangle over here. Got the same thing, don't I? I got a side, got an angle, got a side. So what must be true about that third side right there? They must be equal to each other. All right? If you followed, great. If you didn't, that's no big deal. But they are equal to each other. So if I said this, let's name it ABCD. All right? And if I told you, so if it's a rectangle. Now, by the way, we don't really have like a symbol. I don't think they do a symbol for rectangle. I think they just actually write the word out. Let me just double check. I don't think on a rectangle they do. If you can find it, but I don't think they do. I just think they I just think they put like the word rectangle or RECT for rectangle. They don't really draw a picture of a rectangle, okay, for the symbol. So we'll call this, what do you want to call this? Rectangle what? Yeah, call it ABCD. Watch. So if it's a rectangle, so if this is rectangle ABCD, then what do you think is true about the diagonals? What do you think we can say here? Let's put the actual letters in. So what are my diagonals of this rectangle? Come on, let's pay attention. I got a lot of you guys just letting me do all the work and you're not thinking. Come on, you need to think while I'm asking you these questions. So if I call this a rectangle right here, what could I say about these diagonals? They're equal. Give me the actual letters and the names of the diagonals. Okay, then AC is equal to what? BD. Good. See? You guys can think that through, can't you? So here's the thing. It says if it's a rectangle, if this is a rectangle, ABCD, then what must be true about the diagonals? The diagonals must be equal to each other. Okay, that's one of our theorems for this chapter, this section of this chapter. All right. Is that true about every single parallelogram? Are the diagonals always equal to each other on every single parallelogram? No, they're not. Okay. Now they do bisect each other, don't they? Okay, but they're not always equal. They're only equal when that parallelogram is a what? A rectangle. That's right. Hear what I'm saying? Okay. Sometimes I think just by looking at your body language and your faces, it looks like my words are just hitting you on the forehead and just dropping on the floor. All right. Internalize them. Think about what I'm saying. So what did I say? If this is a rectangle, what's true about the diagonals? They are equal to each other. What's true about a regular parallelogram? What's true about the diagonals on just an ordinary parallelogram? The diagonals are what? They bisect each other. Are they equal to each other on a normal everyday parallelogram? No. Only when that parallelogram is a what? Rectangle. Okay, good. Getting a little bit more feedback. Let's do this. Let's do a little. What if I said that length right here, we'll call that E. What if I said E or AE was 5? What could you tell me then? AC is 10, right. Then AC, the whole thing is 10. Or EC is 5. Would you agree? And then DB. Look, I don't know anything about DB, do I? I don't know any of these little segments, but I do know that they're a diagonal of a rectangle. So guess what? BD has got to be 10 as well, right? And if it's being bisected, that has to be 5 and that has to be 5. So on a rectangle, all 4 of those pieces, watch, put a little tick mark here, 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 and here. Everybody see that? So everything with a yellow tick mark are equal to each other. But that's only true on what kind of a picture, what kind of a figure? A rectangle. That's not always true about every parallelogram. Okay? It's only true when you have a rectangle. Got it? Okay. Good. Let's do another thing. Notice what I did right here. I said if you have a rectangle, then the diagonals are equal to each other, correct?
Yeah.
All right. What if we had this? Let's make that white again. Is that a rectangle?
I don't know.
Good. Good answer. You don't know, right? Nobody knows that that's a rectangle, okay? So it looks like it could be, right, okay? There's a good chance that it is, but we don't know for sure, do we? But what if I told you this? Let's make that a different color. There. What if I told you, yep, what if I said if? Now, I didn't tell you this was a rectangle to begin with, did I?
No.
Up on the other one, I told you right at the beginning, that was a rectangle. This time I'm not telling you that that's a rectangle. I don't know if it's a rectangle, but I do know this. Watch. What if I knew that, wy is equal to xz?
Well, if they were equal, then it would be a rectangle.
Exactly right. So if the diagonals on a quadrilateral, right, I don't know if it's a rectangle yet, but if I did know that the diagonals were exactly the same, if they were equal to each other, guess what kind of figure this thing would be? Then it's a rectangle. What did we just do right there? We switched the if and the then, didn't we? What do we call that when we switch the if and the then? It's a converse. Very good. Good. See, isn't that much more fun answering questions? And you know it, and you know the answers too. So if the diagonals are equal to each other, then I could call this rectangle WXYZ. See the difference? This one up here, above here, I knew that it was a rectangle, so if I knew it was a rectangle, I automatically knew that the diagonals were equal. On this one, I didn't know it was a rectangle, but I was told, it says if, I was told that this was true, that this line, this red line, and this red line right here are equal to each other. So if that's all I knew, that's enough to say that this is a rectangle. And guess what? If it's a rectangle, guess what else I know about this stuff? Well, I know this is parallel and this is parallel, right? What else do I know? I know this is equal and this is equal. What else do I know? I know that the opposite angles are all equal. And then I know it's a rectangle, so I know, right? I know that we got right angles right here. Would you agree? What else do I know? I guess that's about it, right? I know the diagonals bisect each other, right? So this, 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 and this are all equal to each other. There's a lot of stuff I knew. But what was the only thing I was told? The only thing that I was told to begin with was that the diagonals were equal to each other. With that little bit of information, I was able to do all this stuff right here. I used to watch this TV show. You've probably never seen it in your life, unless maybe your parents or your grandparents probably were watching it. It's called the New Yankee Workshop. Has anybody ever heard of that? It's usually on Saturday afternoon. Like I said, you probably never ever watched it. It's on Channel 12, which is PBS, you know, the PBS station, you know, when you used to watch Sesame Street and stuff like that. But this guy, he's from New England. He's from Massachusetts, and he does a lot of woodworking, right? He sees this cabinet. He'll go to an antique store, right? He'll see this cabinet. He'll look at it and he'll say, oh. So he takes some measurements of it. And then he goes back to his workshop and he makes this beautiful cabinet, this old cabinet like over 100 years old. And he makes it from scratch. And it's beautiful and it's just gorgeous. And he could probably sell it for thousands of dollars. I mean, that's what he does. So I was into woodworking a little bit. But one thing he would do, if he had something like he was doing a table or something, he wanted to make sure that it was a rectangle. He would say, we're going to check for square. When they say check for square, it doesn't mean it's an actual square. It means that all the angles are right angles. So what does he have to do? Does he have to take a protractor out and measure all 4 right angles? No, in order to test, and it's a very, very easy test, in order to see that this is a perfect rectangle, guess what he does? He measures from this corner to this corner, and he probably doesn't even know that this is a theorem in geometry. He just knows that this is how you figure out if the tabletop is a rectangle or not. That somebody told him to do this. Watch. So if you measured from here to here, that's one diagonal, right? How could you see if all these are right angles? What else would you measure? You'd measure the other diagonal, wouldn't you? Okay, you'd measure from here to here. If those 2 measurements are exactly the same, guess what kind of tabletop that he has? He's got a nice, perfect rectangle, doesn't he? And he'll say it. I remember him saying that quite a bit. Okay, now we're going to check for square. And then what he does, well, he's from New England, so he's got that New England accent, right? He says, we're going to check for square, or something like that. I don't know. I have to do it New England accent. But he would take a ruler or a tape measure, and he'd take from one corner and he would measure it down from this corner to this corner. Then he'd get whatever the measurement was. And then he would do the other corner from here to here. If they were exactly the same, he knew his tabletop was a perfect rectangle, and all those angles were right angles. He didn't even have to check and measure the angles to see if they were right angles. He knew. And how did he know that? Well, it's taken from this stuff right here. Okay, this is what tells him that that thing's a perfect rectangle. It's pretty interesting, don't you think? Yep, real life situation where you could actually use geometry, right? And there's tons and tons of situations where you can use geometry. It's just one example. Let's do this. I didn't do this in the other class, but I'm looking at one of the problems from the book. So let's do a quick little example here, and then I'll give you some problems to work on. So, now I don't know it's a rectangle just yet, do I? But I'll put some diagonals in here, and they actually tell you that it is a rectangle, alright? So they say that this thing right here is a rectangle. We'll call it Q, R, S, and T. Alright? So at the top they'll say, this is rectangle Q, R, S, T. So we know it's a rectangle. So what must be true about Q, S, and RT? They got to equal each other, okay? Watch this. Let's throw some numbers in here. And let's see what we can do here. 3 and 7. And I think they're going to tell us a few things. The only thing they tell us is angle 2. They tell us angle 2 is 40 degrees. Alright? And what we have to do is we have to figure out what all the other angles are. So let's start right here. Let's start at 40. If this is 40 degrees, yeah, angle 1's 50. How do you know it's 50? Where'd you get that from? That's right, because if it is a rectangle, they told us it's a rectangle, so we know that's a right angle, don't we? We don't have to guess. We know for a fact that's a right angle. So how do you find this? What's the math? 90 minus 40, that's right, and that would be 50 degrees. That was easy so far, wasn't it? Anything else we can figure out? Angle 3 is 40, okay. And you're right. Why is it 40? Well, it's not opposite. It's alternate interior angles. Very good. Because look, since it's a rectangle, we know that those two are parallel, don't we? And this QS is a transversal. Remember that? Parallel lines cut by transversal. Look at this 40 and look at this angle down here. That has to be exactly the same, doesn't it? Because alternate interior angles are equal. Remember doing that stuff? Mary, getting all this stuff? Okay, good. That's an interesting study method you got there. But okay, so we got 40 degrees, and that's 40 degrees right there. I know you can't see it too well, but that's 40. Of course, angle 4 would be what? It'd be 50, right? Because that's a right angle. We took it away from 90. Pretty good. All right, we're on a little roll here. What else do you think we could figure out? That R is a right angle. Okay, that is a right angle. How's that going to help us solve for this? Well, I'll show you something. Watch this. You might have not thought about this, but we've talked about it. Watch. Remember, all these are equal to each other, aren't they? All these segments right here. Remember, because they bisect each other and they're equal to each other. So this little segment from R to the middle, they don't give it. We'll call it R as T. We'll call it U. All right. So RU is equal to SU. Would you agree? Remember, we talked about this? If you have a triangle and you got two equal sides, what's true about the opposite angles? They're equal as well, aren't they? Okay, so look. So this side is equal to this side, so the angles opposite have to equal. So if this angle is 40, guess what this is? That's got to be 40 degrees as well. That's something we haven't talked about in a while, but it works, doesn't it? Remember that? So let's find 8 now. Well, we could do this over here too, couldn't we? Look, these two sides are equal, aren't they? If this is 50, guess what angle 6 is? That's got to be 50 as well because of the same reason. And now we could do 5 and 8 pretty easy. Let's do this. Angle 8 is what? How'd you get 100? Yep. 40 plus 40 is 80. Take it away from 180 and you get 100. Right. Exactly right. So if that's 100, what's this got to be? You could do it a couple ways. Forms a straight line, right? 180 degrees, so 180 minus 100 is what? 80. Or you could look at it like this. This is 50 and this is 50, which is 100, right? Follow me? All kinds of ways you could see this. This is also, you could also look at it this as an exterior angle to these two remote interior angles, right? So these two add up to be 100. It all works out, doesn't it? What do you think? It's kind of fun, isn't it? Doing that? Yeah. That's pretty cool because what? They only told us like two things. They told us a rectangle and they told us one of the angles. And we were able to actually figure out every single other angle. If we wanted to keep going, we could, right? That would be 40, wouldn't it? What would this one right here be? It'd be 100. Which one would this be? 80. Now, it's not exactly drawn to scale, is it? Because that looks smaller than that one, but it says it's 100. But our numbers are right. And then if this is 40, then that's got to be 50. And we pretty much got everything, didn't we? Yep. Okay. All right, so anyway, there you go. There's a few things that you're going to be doing. You know what else they're going to do, don't you? Like TU right here, they're going to say like this is 3x minus 2, and like RU, they'll say it's like 5x minus 1 or something like that, right? Yeah, what do? You set them equal to each other, right? Solve for x and all that kind of stuff. We've been doing that all year long, haven't we? We good with this? All right, so what do you think of rectangle? Rectangle's pretty easy, isn't it?
Yeah.
It's a parallelogram, but it's a special type of parallelogram. Okay, it's got right angles all in it. All right, the diagonals are equal to each other. That's what's different about just a normal parallelogram. Good? All right, let me give you the worksheet and you can work on it.